This is a video, second in a series, on using Solver to maximize or minimize values in linear programming environments. If you recall on the last first video, if you haven't watched it, I would recommend you watch it before you watch this one. But if you recall, in that video, we solved the novelty problem. And what I'd recommend you do is, after you have solved it, if you've saved it, you could end up using it again. So what I would recommend is you denote in words what your objective for that particular solution was, and put it in words down below, because you may come back to that weeks later, months later, and you probably may not remember what the various numbers meant in each of the sections. So this might be a reminder for you. For example, the objective was to maximize the profit, and we stored that value in D4, where the changing cells were B3 and C3, and the constraints we found in that machine 1 could not be used more than 180, and that's when we denoted that in cells D5 through DF, or D5 through F5. And then the other constraint was machine number 2 had to be used for less than 300 minutes, and we denoted that in D6 through F6. Just a recommendation that as you come back, sometimes your memory may not be good enough to remember what you did a month ago or a couple months ago. In this one, I'm going to again use another one that we used in class, and if you remember, we solved a minimization problem where a nutritionist made up a regimen for a particular client and indicated to her, or indicated to the client, that for optimum performance or optimum health, she had to be taking on a daily basis 3 types of take pills to give her a minimum of 2,400 milligrams of iron, 2,100 milligrams of vitamin B, and 1,500 milligrams of vitamin B2. There were 2 brands that are available, so that the client could decide which brand to buy, and would be interested, of course, of finding what the minimum cost would be to meet the requirements of 2,400 milligrams of each, or the milligram requirements for each of the 3 values, or variable vitamins or minerals. Okay? Well, I've already transcribed all of the data that we put in the table. I put that here in the on the spreadsheet, but I've left a few things blank because that's what I want to show you how to do today. Okay, but if you remember, one of the things I did says, let's insert a row above the cost, where I will be able to designate what the changing cells were. And as if you recall, we did that by coloring them yellow. You might want to get a standard that you work on. We'll also want to insert a cell where we're going to put the objective function, and that's objective function is the cost. We're going to want to minimize that, and it's 6 cents for brand A and 8 cents for brand B, and that produce the minimum cost. Again, we colored that one green to remind us that's where the dollars or cents would be located. You remember I also added some additional cells in between there, and in those I'm now going to place my constraints. And that's what I want to show you today. Okay? But first, let's fill this one in. Okay, we know that that the objective function is going to be computed by taking the cost of each pill of brand A, which was 6 cents, times the number of brand A that he's going to take, plus the price of a pill for brand B, times the number of pills they would take, and that would be determine my cost. Okay? Well, now I'm going to put in the other constraints, but this is what I wanted to show you. There is a function in Excel With 3 of them, it's not a big task, but sometimes you're going to find that you might have 10, 15, 20 constraints that you have to deal with. And that can be a lot of work and lead itself to errors if you're not careful. So there is a function that can be useful to us. If you recall that each time what we would do is we'd take the value of A times the number of A plus the value of iron for B times the number of B, and we'd add those two sums together. And we'd multiply 40 times that plus 10 times that, 10 times that, 10 times that, plus 15 times that, and so forth. Well, this function is called sum product. So if you put the equal mark there and start to type in sum and hit a P, you will see it'll find its sum product. What sum product does, it takes an array, the first array that you give it, and then multiplies that array, each element, and that array by the corresponding in a second array, and when it's done, it sums them up. Thus, sum product. So if to use sum product, okay, sorry about that, let's do that again. Sum product. The first array I want to use is the iron array, and I will select it, then enter a comma, and then select my changing cells. Close it with a parand, and now what it'll do, it'll take the first element in B, in row 17, B17, and multiply it by the element in B15, and then it'll element by element and add them up. Okay? Now, the next one down here will be the same, won't it? Except that these will remain fixed, but we're going to want these to change. So I want to make sure that B15 and C15 do not change when I drag it. So I'll go up to here and I'll put a $sign in front of the B. I want to put it there in front of the B and in front of the 15. $sign. And do the same thing for C. $sign. So now, when I drag this thing down, B and C here will increment B17, B18, B19, which is what I want, but it'll keep B15 and C15 fixed. So if I now take and drag that down 3 spaces, it now does and takes this one, takes B18 through C18 and multiplies it to the corresponding elements in B15, C15, and so forth. On a long list, that one could save you a considerable number of typing and most likely a lot of errors. Okay? Since this is a minimization problem, we're going to want to say that that is going to be greater than or equal to 24, because this must be the minimum. At least 2400, so the number we end up there has to be 2400 or bigger. The same will be true there. Greater than or equal to. Greater than or equal to. Okay? Well, I think I'm now ready to implement Solver. Again, I find Solver on the Data tab, select and open it, and now I'm going to tell it where is the objective function, where do I want to put it. The objective function I want to be stored in D16. The cells I want to change are going to be those two, B15 and C15, and the constraints, I'm going to clear those out. And now I want to add those constraints. Well, here's another trick that you can use. Okay? The same thing is going to be true here as was above. So what I could do is this arrange here. Instead of 1 by 1, I could use this array and say the elements of that array pairwise need to be greater than or equal to the elements in this array. And so what Excel will then do is it will take the first element in that column and make sure it's greater than the first element in that column, the second element in that one greater than that one, and so forth through the list. That too can save you a lot of typing. Okay? And that takes care of all my constraints, so I click it. Okay, and there's my constraints all condensed into one line. This is a minimization problem, so I want to make sure I click minimize. Again, non-negative, simplex, say solve. Look at that. It says I have found a solution. All constraints and optimality conditions are satisfied. Okay. And there's my solution. I need 30 tablets of brand A and 120 tablets of brand B, and that will cost me $1,140 or $11.40 is the cheapest that I can find to get those. Okay? I do want to add two things to it here. Okay? One is it gives you the option of creating an answer report, and it gives you the option of a sensitivity report. And I'm going to click both of those and say I want to generate those reports. When I say OK, it creates those reports and places them down on the bottom. So if you go down on the bottom, you will see a tab that says sensitivity report, and over in front of that it will say an answer report. If I click on the answer report, you will see there it says the original value was 0 and the minimum cost was $1,140 or $11.40. Required 30 tablets of brand A and 120 of brand B. And this is what I wanted to point out. Here it tells you that the number of iron and the number of vitamin B are binding, which says you notice there is no slack. And if we remember, we looked in sensitivity and simplex. When we looked at the simplex, we talked about slack variables. It's telling you that there is no slack. It's binding. You needed every bit of it. This one tells you we actually had a bunch of slack in there. It never used the full constraint there. There were still 450 available that could be used. Those you recall you can use to predict shadow prices and a number of other things. We didn't go into in class, but I'd certainly recommend you take a look at it. Okay. The sensitivity report gives you a little more detail. Okay. Here you see the shadow price for tablet B. Well, there's 2 cents for the shadow price of iron and 52 cents per unit, and the allowable increases. And as you read the chapter on sensitivity, that will explain more to you. We're not going to go through that in class. Okay. Well, that concludes this video. Be happy to answer any questions for you if you contact me.